After we've gotten through section 10.1, where we've talked about measuring arc length, and we've talked about area sectors, we've talked about segment area and annulus area, we're now going to talk about what tangent lines are. And it goes through the definition of a radius and a diameter, and we've used that enough finding our areas and our circumferences that we know that a radius begins in the center of the circle and goes to the outside. And the diameter goes from one side of the circle through the center to the other side. And I talked briefly about the fact that a diameter is actually a chord. Okay, a chord has endpoints on the circle. The diameter just specifically goes through the center. Okay, over here you can see what a chord is. A chord has endpoints on the circle, but a chord doesn't have to go through the center. Okay, so the diameter technically is a chord, but it goes through the center. A chord is a segment with endpoints on the circle. Okay, a secant line. A secant line is a line that goes through and touches the circle in two places. Okay, so the secant intersects the circle in two different places. That's a secant line. A tangent line, okay, a tangent line is only going to touch the circle once, and it's going to be the very outside of the circle, where we call that the point of tangency, where that line actually touches the circle, but it's at a single point. That's a tangent line. So this is a tangent line that just touches the circle once. A secant line will intersect the circle twice. Okay, circles are congruent. We've seen that word before. To be congruent means to be equal. We saw congruent triangles where they're the exact same size. Congruent circles have congruent diameters, or the radii, the radius of each circle is the same. That would make the circles congruent. Okay, when we have a common tangent, so here's a tangent line. Here's one tangent. Okay, here's another tangent. Okay, if these two lines that are tangent to the same circle, where they intersect, the distance from that point of intersection to the point of tangency on the circle is always going to be congruent. Okay, that distance is going to be the same. Okay, you're going to see some drawings that look like this. So we've got two different lines that are both tangent to the same circle. Where they intersect out here, that distance from that point of intersection to the point of tangency, those distances are equal to each other. Okay, another thing that we know about a tangent line. Okay, when I have this line that's tangent, here's my tangent line. Okay, here's my point of tangency. Okay, we know if we take the radius to the point of tangency, that's going to be perpendicular at that point. So the tangent line is perpendicular to the radius of the circle at the point of tangency. That's also going to help us out with a few of our drawings. Okay, for example, it says, is segment KJ tangent to the circle at point J? Okay, is this tangent to the circle? Well, this line, this segment, if I extended it in a line, that's a line that is tangent to the circle. This is the point of tangency. So yeah, it's going to be perpendicular right there. Because it's perpendicular, then yeah, it's going to be tangent to it. Okay, another question, it says ST is tangent to the circle R at point S. So that means this is a right triangle right here. This is my, if I extended this, this would be the line of tangency. So at where the radius and that tangent line meet, that's a 90-degree angle. It says what is the length of the radius? Notice that we're missing that length, but we have a right triangle. So I can use that a squared plus b squared equals c squared. Okay, which side am I missing? Well, let's see. Something's wrong with this drawing. Okay, if I look at this, that's the 90-degree angle, then the hypotenuse in that picture is only 18. That's a problem, because that should be the longest side of the triangle. So we've got a drawing there that these should be reversed in the picture. That should be 18, and that should be 24 in your picture. Okay, when I plug those in, 24 is the hypotenuse of that triangle, so it has to go in for c squared. And then I can say 18 squared goes in for a, and I can say the radius is the unknown. Call the radius to b. Oh, that's why. My bad. That is okay, the drawing. That's why. They're not saying that this whole line is 18. They're just saying from here to here is 18. So we got to factor in the radius to that distance. That's why. Okay? So yeah, that is going to be the c value. But it's not just 18. It's 18 plus x that I have to square. Okay? This would be x squared plus 24 squared. So actually it does work out. Now we aren't going to solve these because when we square, okay, you're not going to see anything like this on your worksheet. But when I square that, I would have to get a trinomial out of that. That would actually be x, if I put it in the same order, 18 squared is 324 plus 36x plus x squared. I don't know if you remember that from Algebra 1 or not, but when we take a binomial and square it, we get a trinomial. Over on this side, we get an x squared plus 576. This isn't too bad to solve because when you have an x squared on both sides, they're going to cancel each other out. We could subtract 324 from both sides. So I would end up with that would be 252 equals 36x, and then I could just divide by 36. X is equal to, what would that be? 7? I took it times 7, that'd be 42. Yeah, so x equals 7. So the radius of that is going to equal 7. That makes that 25. 18 plus 7 would be 25. That's better. Okay, here's another last example in your packet. Okay, it says the distance from T. Okay, difference from T to X is 12. T to X, that would be the radius, is 12. From T to Z is 20. T to Z, this would be 20. And they want to know, find X to Z. They want this distance. Or Y to Z, they want this distance. And they want T to Y, they want this distance. Well, this distance is the same as that. It's a radius, so this has to be 12. Okay, T to Y has to be 12. Okay, and then for both of these, I'm just finding, I can take one triangle. These distances are going to be the same. I can take one of these triangles and solve it, and I'll have the distance for the other two sides. This is a right triangle. Okay, 20 is the hypotenuse, so I'd say x squared plus 12 squared equals 20 squared. X squared plus 144 equals 400. Subtract 144 from both sides, and I get x squared equals 256. So if I take the square root, x is equal to 16. So that distance on both sides would be 16 units. Right, so those are some things about tangent lines and how we can use those to solve for different distances. You have a worksheet that you can work on.